Students, hey, here we are with the last recording for the week. Yay. Okay, so obviously you can't private chat this to me, but hopefully you answered it. After booming and zapping is when I emerge to bring you bright, dazzling beauty when I diverge. Some said I hide enormous wealth, but those riches have always proven stealth. What am I? And at first I thought it was, oh, these are like fireworks, right? Like booming and zapping. No, it's a rainbow. So, at the end of the rainbow, pot of gold. Yeah, okay. Anyhow, hopefully you get that riddle. All right, you guys, today is lesson 6.06, independent and dependent events. And you're going to see that this is so very similar to what we did yesterday. You're going to get tired of my calendar items, but you're not going to forget this. So, today is the last day for watching a recording. Remember, we don't have live class tomorrow. And then next Friday, I will be zeroing out gradebook. And the 24th, 2 weeks after that, all assignments, work, tests, whatever are due. Okay? All right. So I thought I had several students email me and had questions about some things on yesterday's assignment. So I thought I'd better do a quick review and talk about a few of the questions that were on there. This was one of the most missed questions, and I had students email me about this one. So I wanted to make sure you understood. So let me go through this. First of all, it says an activity book has 21 pages of crossword puzzles, 18 pages of cryptograms, and 12 pages of mazes. So right there, my mind is automatically going to, okay, well, how many total pages do we have? And so let's write that number over here. If I was to add 21 and 18 and 12, I get 51. Okay, so there's 51 total pages in this activity book, we can say. Bianca randomly selects a page. Okay, so she flips through it. Oh, going to do this page. Completes the activity. So therefore, if she completes it, we now are without replacement, right? We are not putting it back. We're not like clearing the page or erasing it and we get to choose it again. It's no longer available for us to choose. And then randomly selects another page to complete. So this is what we're trying to find. What is the probability that Bianca first completes a maze? Okay, so when we have something like this, we have to start with, and it's without replacement, we have to start with the first activity. So maze, and so I have to go up here and find which of those numbers is the maze. Well, here I see 12 pages of mazes. So I'm going to put that as my numerator. And remember, the denominator is always the total, so that goes on the bottom. And then the next thing says and, so there's my key multiplication. Okay, and then completes a crossword puzzle. So I go to crossword puzzles. Now, there are still 21 crossword puzzles. We didn't complete a crossword puzzle the first time. We're assuming that we completed a maze, okay? But because we completed a page, there are only 50 pages left. Do you guys see that? Okay, so then when I multiply, change it to a decimal, all of that jazz, this comes out to be 9.9%, rounded to the nearest tenth of a percent. And so you can go ahead and check or do your work up to that point and double check to make sure that this is what you get. All right, hopefully that answered the questions that you have or had. All right, let's do one more. There are 20 golf balls in a bag and 2 of the golf balls are white. Okay, so 20 is my total. I'm going to start with that, okay, just so I can remember. If 2 of them are white, then 18 have to be yellow, right? So I'm going to write 18 right here because I know that there's only 2 colors, right? Yellow and white, and so the remaining have to be yellow. Sherry randomly chooses a golf ball, looks at the color, and returns it to the bag. Oh, there it is. There's our key, returns it to the bag. Therefore, this is with replacement, right? All right, she mixes up the golf balls and randomly selects another one. What is the probability that Sherry selects a yellow ball both times? Okay, so now I go to, well, how many yellow balls are in the bag? And we discovered that it was 18. So 18 goes on top. Guess what? I put it back in, so I still have 20 golf balls. I still have 18 yellow. So my second probability is still 18 over 20. And then, of course, we go ahead and multiply. And I think I will let you guys finish this. Don't forget once you get it to a decimal to move it 2 places to the right, so that you can have it as a percent. All right. So today's lesson, 6.06. Our objectives. I can determine if events are dependent or independent. So that will be saying whether they're dependent or independent, just identifying them. Find probabilities of independent events and find probabilities of dependent events. So you will have questions that look like these on the board. Which events are dependent, which events are independent. And then you'll have questions where they're asking you to find a probability. These ones are, I think, all asking for you to round to the nearest hundredth, which means you don't need to change it to a percent. Write your answer as a decimal, okay? So pay attention to those directions, please. All right, moving right along. Here's our information to save page. So let's start here with the definitions. Let's talk about two different words, independent and dependent. Independent. Two events are independent if and only if knowing one outcome has no effect on the probability of the other. So what this means is they don't depend on each other. They are separate from each other. This is kind of like with replacement. Okay, so this is like the same idea. Independent goes with replacement. Okay, so I'm going to put in parentheses here with replacement because that's how we're going to remember it from yesterday's assignment. So that W and then we'll put with replacement. Oh, I wish I could type on here. Replace. We'll put with replace. Okay, you guys okay with that? Abbreviate it a little bit because Mrs. Guyman is struggling with this crazy pen. Okay, so then we have something kind of the opposite of that, right? So this one is dependent, and dependent means that one event depends on the other. So this one I would be without replacement. And the reason why it's without replacement is because if we don't put that golf ball back in the bag, the second probability depends on what happened the first time, okay? And so we know that that would be without. I'm going to write this and then out. And I'm going to pause this for just a second because my battery is going to die and I need to get my computer plugged in. So just a sec. Okay, students, here I am back. All right, dependent without replacement, right? Without replacement. So here are our probabilities, and you're going to notice that it looks so much like what we did yesterday. There's just this weird kind of looking thing down here, and I'll explain that to you. But if events A and B are independent, so here's my independent, and let me keep it green since I had it green up there. You can see that our probability is just going to be to take the first probability and times it by the second probability, which is exactly what we did yesterday with replacement, right? We just did some examples of it. If events A and B are dependent, so now we have dependent, then this is the situation. Now you're like, but Mrs. Guyman, yesterday we had P given B after A or something like that. So look, you guys, it means the same thing. It's just a different way to write it. Where P and then this thing right here, B given A, is the conditional probability of event B or event A given B. Okay. Given that A has already occurred. So what's saying is that we've taken it out and we're not putting it back. So we've performed the first experiment, the first event, and then we're going to perform the second one, but we're not replacing what we took out. We're not, erasing the pages. We're not tearing them out. You get the gist, right? So it affects what happens the second time, and that's why it's dependent. The second event is affected by what happens on the first event. Okay, a couple tips over here. So first of all, remember that probability of red, given red, means that the probability of getting a red on the second pick, given that red was the outcome on the first pick. Okay, a tip, the property for independent events extends to 3 or more events. Okay, so independent extends to 3 or more events. With replacement means the object is replaced before the next object is chosen. In general, events are independent when there is replacement. Without replacement means the object is not replaced before the next object is chosen. In general, events are dependent when there is no replacement. So this is exactly what we said up here when we put with replacement and without replacement. Okay? All right, take your snip, finish writing your notes. If you need to pause me, go ahead and pause me and write this stuff down. Otherwise, I'm going to continue on. I guess that's the beauty of a recording, right? You can pause it whenever I'm going too fast. Okay. So obviously you can't give me thumbs up and thumbs down, right? Well, you can, I guess, in your imaginary mind or while you're watching the recording. But let's look at a thumbs up and thumbs down situation here. So we're going to give thumbs up if it's independent, thumbs down if it's dependent. This is just to determine if they're independent, dependent. So look, flipping a coin multiple times. So when you think about flipping a coin multiple times, am I going to cut the coin in half? Am I going to take one side off? No, right? I'm taking one coin, I'm flipping it. It doesn't matter what happens the first time. It's not going to affect what happens the second time or the third time. So this one would be a thumbs up, right? A thumbs up because this is independent. So I'm going to put an up arrow, okay? This one, rolling a number cube multiple times. Once again, it's one number cube. I'm obviously not going to take out one side. I'm going to keep all the sides in there. So this is still independent. Okay, picking cards from a deck without replacement. Ooh, that means I'm not going to put it back. That means whatever I pick out the first time is going to affect what I get next. So that is dependent. So we're going to put an arrow down, right? A thumbs down. It's backwards. Picking marbles out of a bag with replacement. Oh, I'm going to put it back. It's kind of like the golf ball one that we did before. Thumbs up. So that would be independent. All right. Hopefully you understand and get the gist of what's dependent and independent. So let's do some examples of how to find probability with these now. So I gave you a hint on what kinds of questions these are because I told you up here that we're finding probability with independent events, which means there's replacement. Okay, so when I do a question like this, on a television game show, a contestant has a chance to win a car, okay, by rolling 5 number cubes. Each cube has 3 faces with pictures of cars and 3 faces with amounts of money. Have you guys ever watched Price is Right? Because they have a situation just like this on there. The contestant wins the car if she rolls a car on each of the 5 cubes. What is the probability expressed as a percent that the contestant wins the car with one roll of the 5 cubes? Okay, so you guys, it doesn't matter what happens on the first dice because cube. I'm gonna roll a whole new cube. Okay, but I want to know what the probability that the contestant wins the car on one roll. Okay, this is what's going to happen though. She's going to put all 5 of them and roll them at the same time. Okay? So like have you ever seen it? This really is a game on Price is Right. They put them in like this big tub and then they shake it and then they roll it out and it rolls down the thing and then it shows. Okay, so that's what we're doing here. So we're going to do 5 probabilities, right? 5 of them because we need to know what happens on each one of those. Okay, and I'm going to put little time signs in between all of them because we're combining these. Oh, that's not a very good. Oh, these are so bad time signs, you guys. This pen is so much harder than the one in Blackboard. But it's way easier to record it this way than it is in Blackboard. Plus, then if you can't get Blackboard to open, you can always get this to open. Okay. Okay, let's just use a little X for times because that's working way easier than trying to put a dot. Okay, so now, because it's replacing, it's independent, I know that each side has 5, the number cube has 3 faces with pictures and 3 faces with money. So I have 6 sides, right? 6 on every single one of them. So that's my denominator because that's not going to change. All right, now, oh, so sorry about that. Okay, so now the idea here is that we want to know if she can win the car. So I'm just looking strictly at the faces with cars, right? So it says that there are 3 right here. So I'm going to put a 3 on top of every single one of these. Oh, wait. The contestant wins a car if she rolls a car on, yes, on each of the 5. Yes, she has to get a car on all 5 of them. So we're going to put a 3 on all of these. Do you guys think this probability is going to be likely, unlikely, impossible, or equally likely? Because I think it's going to be unlikely. Okay, now we're just going to multiply all these together. Okay, multiply them together, and then it wants it as a percent. So I'm going to go ahead and do that work. Okay, students, there's my answer. I changed it, multiplied it, changed it to a decimal, and then to a percent. If you can't read that, that's 3.1%, not 3.11 or something crazy. So pretty unlikely, right? 3% is not very likely. Next one. You spin this spinner 4 times. Okay, so once again, I've not only given you a hint at the top, but if you're spinning the spinner 4 times, it's not like you're going to take a section of the spinner out, right? What is the probability of spinning an odd number each time? Okay, so look, 4 times. 1, 2. I always start with how many of what I'm doing, okay? 4. What is the probability of spinning an odd each time? So remember, the denominator is always the total. So if I count, I have 1, 2, 3, 4, 5, 6, 7, 8. So because it's independent and I'm not taking something out, they're going to all be 8, right? And then odd. I want to know if I can get all of them being odd. So I count how many odds there are, right? So 1, 3. Oh wait, this is not in very good order. So let's see. I'm going to change it to red and do, there's an odd, that's 1. Ooh, 3 is an odd, that's 2. I only see 2 odds. So I'm going to put a 2 on top of each of these. And then once again, multiply and divide. It doesn't say what to leave it as, so all of your assignment ones say leave it as a decimal to the nearest hundredth. So let's go ahead and do a decimal to the nearest hundredth. So I'm just going to multiply those and then change it to a decimal. Oh, you guys, I had to round this to the nearest thousandth. Otherwise, it would have been 0 because it was 0.0039. So we had to round it to nearest thousandths. That's pretty small. That's like less than 1% because if I move my decimal 2 places, that is like 0.5%. Isn't that crazy? Okay, so very unlikely that that's going to happen all 4 times. Now, maybe one of those times it could happen. All right, so let's head to without replacement now. Okay, let's head to without replacement and let's look at some questions with that. Okay, so what is the probability of picking 3 hearts from a standard deck of cards when you do not replace a card after picking it? Are these events dependent or independent? Well, obviously I've answered that question for you. We know that they're dependent because of this idea that it says do not replace, right? And we know that that's without replacement is the same thing as dependent. So now you have to know how many cards are in a standard deck of cards, right? That has to be our total. So if you don't know that, if you ever heard of 52 card pickup, that's how I remember how many cards are in a standard deck. Because that means you drop all 52 cards and then you have to pick them all up. So that's how I remember it. But if there are 52 cards in a standard deck, we want to know what the probability of picking 3 hearts is, okay? Well, that means we're doing it 3 times, right? We're going to pick a card, leave it out, pick another card, leave it out, so forth. So before we look at the numerators, let's kind of talk about what happens to our denominator. Just like without replacement, the denominator decreases by 1, right? Because we're leaving out that card. So each time it gets 1 less. And so you can see that it goes down from 52 to 51 and then to 50. Now, thinking about how many hearts there actually are 4 suits in a standard deck of cards. So knowing that there are 4 suits, if we take 52 and divide it by 4, that will tell us how many hearts are in the card or in the deck. So there are 13 hearts in a deck, standard deck. So the first one, the numerator will be 13. Now think about this for a second. If we leave that heart out, we're going to assume we got a heart, okay? Because we want to know picking 3 hearts, okay? They're the same. So assuming that we got a heart, now we only have 12 because we left that first one out. And then we only have 11. So see how they decrease each time because we're not putting them back in. We're keeping them out. Okay, I'm going to go ahead and do the math, multiply, divide. It doesn't say to change it to a decimal or percent anything, but I like to leave them as go to percent, so I'm going to go all the way down to a percent. Okay, there's my percentage, 1.3%, not 1 comma 3, 1.3%. So pretty unlikely that you're going to get 3 hearts out if you were to draw and leave out, right? All right, let's do another one. The cards below are in a bag. So think about these being in a bag, right? So here's my big brown paper bag. Okay. You randomly select one card, then another without replacing it. So we're going to take a card out, leave it out on the counter, then we're going to pick another one out. What is the probability of selecting an even number each time? Okay. So I don't know what the probability of selecting an even number each time. Now, if you think about it, these are obviously dependent, right? Because we're leaving it out. But there are a total of 1, 2, 3, 4, 5 cards in the deck. So we're going to put a 5 as the denominator for the first one. We want to know, you randomly select one card, then another without replacements. Okay, so we're only going to select it twice. Sorry, I had to make sure I read it correctly. And so the next one is going to be a 4 though, because we're going to leave out the first card. And we want to know even, so we count how many evens there are. There's 1 here and 1 here, so that's 2 out of 5. And then say we got an even, because we're going to assume we got an even, because remember we're trying to find the chances of this happening. So now we only have 1 out of 4, and so then when I multiply, we get 2 20ths, which reduces down to 1/10, which we know to be 10% basically, right? And so that's not too bad, but you can see, well, it's better than the other percentages, I guess. Still pretty low, right? 10% is not that great, but it's better than the 3 and the 0.5% we've been getting, right? Okay. All right, you guys. We have one more question, and then it's going to be time for your assignment. So hopefully we've done enough problems. I felt like yesterday maybe I didn't do enough problems, so I wanted to make sure I did enough for you this time. A bag contains 4 green, 4 red, and 2 blue crayons. So right there my mind's going to how many total? 8 and 2. Well, 4 makes 8. 8 and 2 makes 10, right? So there's 10 total. Okay, so I'm just going to take note of that. What is the probability of randomly choosing 2 red crayons without replacing it, right? First of all, I want you to think about it for a second. Do you think this is going to be a really low percentage, a pretty low like we got on the last one, or a high percentage? So there's more reds in there, right? The same amount as green. Okay, so I know that my denominator has to be 10. For the first time I pick it, right? And there are 4 red, so I'm going to say, oh, I have 4 chances, right, on the first time. But then for my second chance, it says without replacing it. Now I only have 9 crayons in the box, or bag, I should say. And we're assuming we got a red one the first time, and so I only have 3 out of 9, just like we did with the last problem. So we get 12 over 90, and then change it to a percent. And I think I'll let you guys finish with that. So pause it and finish it. Hopefully you can get it from there. If you have questions, please don't hesitate to send me an email. Send me a message. Let me know. I will put the answer up here. So pause it and finish it. All right, students, hopefully you got 13%. Here's your assignment, 6.06. Complete it now. You have 3 attempts. Password, there it is. Make sure you capitalize the A and the H. All right. Thanks, guys. Have a fabulous weekend. Remember, no class tomorrow, but please get caught up on anything you're missing, especially from Unit 6 from this week, and anything else you're missing, because we are down to 2 weeks before everything needs to be turned in. No, 3 weeks, because we have 1 more week counting next week. Yeah. Okay. Any questions? Let me know. Thanks. Have a good one.